Here in this video, we are solving questions from semiconductor devices that appeared in NEET 2022 examination. Right, there are two questions. Let us see what is that first question is. In a half-wave rectifier, if the input frequency is 60 Hz, what is the output frequency is? So we need to understand first of all, what do you mean by input frequency and so. First of all, we need to know what do you mean by rectifier. Rectifier is a device that converts alternate current into direct current. Here diodes are used, PN junction diodes are used. There are two kinds of rectifiers called half-wave rectifier, where one diode is used. Second one is the full-wave rectifier, where two diodes are used with a central tap. Here in this video, we are talking about, the question is talking about half-wave rectifier. I am not going to explain the functionality of a half-wave rectifier, but we can say input of the half-wave rectifier is like this, an AC source, and the output is in such a way that wherever there is a positive peak, it is converted into output. Wherever there is a negative peak, it was not converted into output. You can notice the output is not actually flat, having some AC components too. So it's not a perfect device. So it is having some AC components, and we can use filter circuits to eliminate the unnecessary components that were there. But one thing that is clear is, for each of the wave there is one component. So if this has a frequency n, this also output also has a frequency n. As the input frequency is 60 Hz, output frequency is also 60 Hz. That's how we solve that simple question. That is question number 34. Now let us solve the last question that is available. That is question number 50. Question number 50. This question. If you look at this, this is A, this is B, and this A is getting like an input here. For this NAND gate, it's an AND gate. AND gate is having a NOT gate to it, like a circle form, so it's an AND gate. The second input of that NAND gate is directly coming from B, so this is B. So if it is AND gate, it could have been A dot B. It's a NAND gate, so A dot B whole power bar is the input of that. Look at the second gate. This is the first input of the second gate, but from the A there is a NOT gate. That means before reaching this place, A becomes reverse of that A bar. This is B itself. If it is AND gate, it could have been A bar dot B, but being a NAND gate, whole power bar is there. These two are the inputs to this AND gate, so output will be A dot B, that's the first input, dot A bar dot B whole bar. This is the second input. That's the output that we have. So we can check what happens for the inputs of A, B, and the output is this. What is that? A dot B whole bar dot A bar dot B whole bar. That's what we need to check. What is that output is, right, for a given input. The possible options are, luckily all inputs are given in the same way. So I can start with A equal to 0, B equal to 0. Here you put A equal to 0, B also equal to 0. Then what happens? 0 dot 0, 0 and 0 bar. 0 and 0 is 0, because AND is an intersection function. It works only when both the inputs are yes. But both inputs are no, so AND output is also no. But bar is there, therefore it becomes 1. Here A bar 0 na A bar means it becomes 1 dot 0. 1 dot 0 is 0, whole power bar is there, dot 1. So 1 dot 1. 1 dot 1 is automatically equal to 1. So for A, B 0, the output is 1. So what are the options that we have left out is, this could be correct, this could be correct, These two are definitely wrong. So I can eliminate option B and option A. I only have to look for option C and option D. Let's give these options like 0 and 1. A is 0, B is 1. What happens then? When you give A equal to 0, here is 0, here is 1, 0 dot 1, mean 0 and 1. 0 and 1 is 0, but whole power bar is there, that means that is equal to 1. Here A bar, as A is 0, A bar becomes 1. Dot B equal to 0, 1 dot 0 is 0, whole power bar is there, that is 1. Right? Here I missed something. Here I missed a small thing like A bar being A is 0, A bar becomes 1 and B is 1 actually, B is not 0 because we have taken these options. So 1 dot 1 is 1, whole power bar means 0. So the second option has to be 0. So this is 0, this is also 0. So there is nothing to in fact check that actually. We can't eliminate it. We can check for 1 and 1, so that because the options are different, right? So what happens if A is 1, B is 1, A dot B is 1, whole power bar is 0. A bar dot means 1 bar, that is 0 dot 1, that is 0, whole power bar is 1. 0 dot 1 is 0. So this is the right option. So the setting D, that like for 0 1 that is 0, for 1 0 that is 1, for 1 1 that becomes 0. So option D is the right answer. I need to just check the basic digital algebra to verify what is given correct and what is given is not correct. That's it, and thank you for watching.